Hello, good morning, everyone. So today I am the presenter Milan Taman, going to present about the mock training. The title is Designing a Real-Life Mathematical Problem, the topic of cylinder using problem-based learning. So I'd like to thank my course facilitator, Mr. D.R. Sinkara, for providing me this opportunity to present my topic. Now let's talk about the outlines of today's this presentation. First one is training objectives. After that, we have fun activity and then introduction of the topic, and mock training activity, knowledge scenario, information hub, worksheet, and finally we have conclusion. Now, what are the training objectives which we are going to achieve after this presentation? The first one is it develops critical thinking and problem solving skills through engagement with real life problems. Second one is enhances conceptual understanding and the ability to apply knowledge in practical situations. So after this, using this problem-based learning, the participant will enhance their conceptual understanding. And now let's talk about the fun activity. So as you can see here, there are 9 sticks. So we have to make it 10. Can you make it? Well, so I'll talk about this one. So here are 9 sticks. We have to make 10. How can we make 10? Is that when we write here 1 stick. Okay, so let's talk about our main topic, that is problem-based learning in mathematics. So what do you mean by problem-based learning? So it is student-centered, not teacher-centered. It is student-centered where learning begins with a real problem. So this problem-based learning always start with the problem, real-life problem, which are found around us. So here, the teacher. Now, what are the benefits of problem-based learning in mathematics? First one is enhances conceptual understanding and problem-solving skills. The second one is it develops critical thinking, creativity, communication, and collaboration. Another, it increases students' engagement and motivation, and it helps students apply mathematics in the real-life context, builds confidence and independent learning skills. So let's talk about our mock training activity. Our activity is designing a mathematical problem on the topic of cylinder using problem-based learning. So what are the outcomes for doing this activity based on cylinder? So after completion of this activity, the teacher participants will be able to design a real-life mathematical problem related to the cylinder using problem-based learning rules. Another one is identifies the required information like radius, diameter, height for solving cylinder-related problems. First of all, we have to understand the real-life context related to the cylinder. So we can select one real-life object, that is cylinder. So it is in the form of cylindrical shapes like bottle, pipe, drum, gas cylinder, or water tank, which you can see here the figure. There are so many diagrams which are in the structure of cylinder. After that, we have to make the problem. So the example is there is a context. Assume that your skill is going to install a new cylindrical water tank to ensure sufficient water supply The total amount spent on sheet metal and painting is 25,000 at the school. You have been given the task to do by your team. You have to find out the best radius and best height that will contain at least 5,000 liters of water, but the construction and painting cost must not exceed the budget. Suppose that the price of sheet metal along with painting is rupees 750 per square meter. So this is the real life scenario, real life problems. Now we have to design the question based on this. Now information hub. So we have to give the full information about the problem, like formula, whatever the participant needs, we have to provide those things. Like formula here, the volume of cylinder is pi r square h, curved surface area is 2 pi r h, total surface area is 2 pi r plus h, and the total cost that is rate into surface area. So these are the information hub. Now we have to give some writing steps also. We should not completely give the full steps. We have to give some steps here. So which I have shown here. I've given some steps, and participant follow the steps, or participant solve the questions based on these steps. After that, after uh, completing those problem scenario, the participants will be given the worksheet. So I have designed the worksheet like this. So here, the group name. So participant will write the name there. Cylindrical object is chosen. So what type of objects in the shape of cylinder they have chosen. They have to write the name, and after that, they have to design a real life scenario here. After that, they have to design the questions. So here are 6 questions they have to design based on the Bloom taxonomy. And what are the mathematical concept is used in this problem? They have to write trick here. And what type of formula they have used here? They have to write the formula steps here, formula and solution steps, and they have to write the final answers and conclusion. So in this way, I have designed the worksheet which the participant has to complete during. Now the conclusion. So what conclusion can be gained by the participant after this activity or after this problem-based learning? First one is it helps to understand how to design a real-life problem-based learning task in mathematics. So after this activity, first of all, I give the process, I give the one example, and after that, the participants design the questions, the real-life questions and real-life scenarios, which help the participant to for listening to me, all my colleagues, respected sir, for providing me this opportunity. Thank you.